All right, last unit. Exciting. Tomas.
Last unit.
Last unit, man.
What does it, that radio does when we go?
What?
What do they do when we go?
I don't know yet. I'll come up with something. All right. So we're going to learn about the antiderivative, and we're going to start with polynomials, just like we did with the derivatives. However, I can only do that if Tomas stops talking. And Lucas. Explaining what? Do it later. Do the lesson first. Okay, so our bell work. We got to review how to take the derivative if we're going to undo the derivative. So, I know many of you already got that first one correct. So what did I do on that first one? How? What is y prime? 6x plus 2. Perfect. All right, what about the next one? Someone else. Marco, stop talking.
Negative sign.
Negative sine 3x times 3, because we got to do the chain rule, right? Amazing.
If you omit the parentheses instead of the dot, it's okay.
Yeah.
What is that? Times 3.
Why?
Next.
Because the derivative of the inside.
Yes, but that thing, that dot is a times.
Yep. Yep, raised dot just means times. Multiplication.
Oh, I know, but I didn't see it.
Mm.
No, wait.
Oh my God, Martine. What?
1.
Ugh, are we ready? All right. If you had to explain to someone how to find the derivative of a polynomial function, what would you say? No, what's your steps? Nope. What do you do with the exponent? The power rule, guys. Yeah. So you multiply the coefficient by the exponent. And then what's your second step? What did we do? We subtract 1 from the exponent. Good. That's easy enough. So if we want to do the antiderivative, we'd have to do the opposite of that. So what would we do first? Well, you got to do them in opposite. So subtract 1 from the exponent would mean that we need to add. So we add 1 to the exponent. And then now we divide. So we divide divide the coefficient by the new exponent. Does that make sense? Right? We just do them in reverse, exactly like algebra, right? When you're solving for x in an algebraic problem, right? You do the order of operations in reverse order in order to try and isolate the x, or the variable. This is the same, right? If we multiply by the exponent and then subtract 1 from the exponent, well, the opposite is to add 1 to the exponent and then divide by that new exponent. Okay. So, the antiderivative of a function is denoted with this notation, this kind of S-looking thing here. Okay? So when finding the antiderivative of a function, you're finding the function of which f of x is the first derivative. Okay? This allows us that if we are given f prime, we can find f. So we can work it backwards. And we can even do this further. If we find f double prime, we could find f prime and then f, right? By doing it twice. All right. Now here's the problem. If I integrate f prime of x to get f of x, what did I not deal with? What did I forget about? This might be easier if you think about f of x and taking the derivative. What disappears? If I take the derivative, what thing disappears? The what?
The exponent.
Not the exponent. It gets smaller, but there's something that goes to 0. Becomes 0. Not the variables. The variables reduced by 1. A constant, right? The derivative of 4 is 0. So if I integrate, how do I get the 4 back? So the problem, right, is the c, the constant. Okay? And what I mean by that is that if I integrated f of x, or f prime of x, I'm going to get f of x, but I need the plus c. Do I know what the constant is? No. There's ways that we can find it, and we'll do that later. But for now, we just have to say that there's a constant there. So we're just going to say plus c. That's all we have to do for now. Okay, say there's a constant, and so we say plus c. Okay. So let's try this then. Let's try doing the antiderivative of these functions. So remember, our steps were to add 1 to the exponent, divide by the new exponent. So this is 3x add 1.
We don't need to put that thing.
Where? This? No, because we're actually solving it. We are doing the antiderivative. So 3x squared plus 1. 2 plus 1 is 3, so we divide by 3. The next one, let's not write out the whole thing. So 2x squared, because we add 1, divide by that new exponent. If there is no exponent, what do I add? Yeah, like if there's no variable, sorry, like I add x to the power of 1. So I would get plus 3x, and the very last thing I need? Plus c. And I guess technically this is divided by 1, but do I need to show that? No. Now, can I simplify any of this? Absolutely, right?
Sir, I didn't understand. Why is there, if we're finding that derivative, why is there fractions?
Well, because remember, we're not finding the derivative, we're finding the antiderivative, and what we had to do is add to the exponent, then divide the coefficient by the new exponent. So my exponent was squared, it became 3, so I have to divide by 3. Now, these are going to simplify though, because the 3's cancel and the 2's cancel. That won't always happen. Okay, but when it does, we might as well do it. So x cubed plus x squared plus 3x plus c. Guys, here's the beauty of this. If I ever want to know if I did it right, what could I do? Take the derivative. So take the derivative. What's the derivative of x cubed? This is like our check.
Mr. But I have a question.
Yeah?
I don't know if you said it. Why did you cancel 2x with 3?
Well, because I didn't cancel 3x, I canceled 3 by 3. So somebody over there said it, yes, it's 3x squared plus 2x plus 3. Is that what I started with? Then I know I did it right. That's the beauty of this, is I can immediately check to see, did I do it right? And I did.
Going back.
Yeah. So you don't have to do this part always, but it's the check that lets you quickly see. All right, so here's what we're going to do. I'm going to leave it like that. I want you guys to try that next one. Try it on your own. I'm going to give you like a minute. All right, so you had a chance to do it. No, I want you to try it.
No, it's just, I don't understand why you check my.
Because we always divide by the new exponent. All right, guys, bring it back. You guys should have done it now. Let's check it.
4x.
Tomás. Just wait. Jose. Tomás, I'm going to kick you out in about 10 seconds. Because I've called your name 4 times. Stop talking. Lucas.
Do I write a fraction of 4x over 2?
Not over 2. Because I add 1, so it's 4x to the 4 divided by 4. And then, Luciana, you were saying if there's nothing, what do I do? Well, this is like having x to the power of 0. So I add 1 to get 2x. And the very last thing I have to include? Good. What's the last thing I could do now to simplify?
Check.
Well, I can check it, but I can cancel these 4's first, right? So x to the 4 plus 2x plus c. Okay, let's do our check. Let's see if we did it right. So I have x to the 4th plus 2x plus c. The derivative, 4x cubed plus 2, and the c goes away. Is that what I started with? I did it right. Amazing. Okay. What if they're a little bit trickier, where they are polynomial-like? So this is where it's not actually a polynomial because, of course, these have negative exponents. Or they could be fractional exponents, right? So we need to deal with those. But the process is exactly the same, okay? So, exactly. So this would be 5x. If it's negative 2 plus 1, what does it become? Negative 1. And then I would divide by negative 1, which might be easier to just write that there's a negative in front. Do you see what I mean? Like dividing by negative 1 is the same as just multiplying by a negative 1. So it's probably easier to do that. Okay, let's do, huh?
So we're going to multiply it or divide it?
You're dividing, but dividing by negative 1 is the same as multiplying by negative 1. Here, let's do the division this time. So we'll divide by negative 1. Okay, this one is going to be 3x1. Negative 3 plus 1, negative 2. Now this one we definitely have to divide because it's not just 1, it's 2. And then minus the 1 becomes 1x. Or if you prefer, just x, right? And then plus c. Exactly. Now, when we have a question like this, usually we don't want to leave it with those negative exponents. So let's go ahead and simplify, and it would be negative 5. We put the x onto the bottom, right, to get rid of that negative 1. Then over here, I've got minus 3, and I'm going to move the x squared to the bottom, so 2x squared. And I also move the negative to the front because it's easier.
Why does it become minus 3?
Because if this was plus 3 over negative 2, that's the same as minus 3 halves. So it's just an easier way. Rather than writing the negative on the bottom and saying plus negative, we just say minus. Okay? Now, the last thing we should probably do is do our check, because this one's a little bit trickier. So I am going to go from this step here rather than this one, because the first thing we would do to take the derivative is put them back up as negative exponents. So we're going to go from negative 5x to the negative 1 minus 3 halves x to the negative 2 minus x plus c. Let's take the derivative. Negative 5 times negative 1 becomes positive 5. Subtract 1, and I get negative 2 in my exponent. This one here, the negative 2 comes down, so I'm going to get negative 3 halves times negative 2, which is positive 3 halves times 2 x to the negative 3 minus 1, and the c goes away.
But that is not obligatory.
No, this is the check. If I want you to do it, I'll say check. If not, you can do it to make sure you're doing it right. I like to show it here so you can see. What is the one thing I would simplify? Well, these 2's would cancel, and now do I have the exact same thing I started with? Yes, I do. So I did it right. Okay? My check shows me I did it right. So now, you're going to try the next one on your own. All right, so this first part was negative 2x to the negative 1 divided by negative 1. Correct?
Yes.
Plus x. This one's a little bit tricky because there's no exponent there, but if there isn't one, it still counts as a 1. So we add 1 to get 2, divide by 2, and then plus c. Now there's a little bit of simplification I could at least do over here, because what happens to negative 2 over negative 1? So we get 2x to the negative 1, or 2 over x if you prefer, plus x squared over 2, plus c. I'll do a check real quick, just to show us that we did it right. 2x to the negative 1, plus x squared over 2, plus c. The derivative of this is going to be negative 2, subtract 1, so negative 2, plus 2x over 2, and the 2's cancel, and I get exactly what I started with. This one? Well, that's the derivative part, guys. That's why I'm going fast. We've been doing that for the last, month and a half. This is just the derivative. X to the negative 1. This part. Okay. It's always the same step, Tomas. Add 1 to the exponent. So if I have negative 2 plus 1, I get negative 1. Okay, so this one is all the same. This is x to the power of 1. So 1 plus 1 is 2. Divide by 2. Make sense? Yeah, we just don't write x to the power of 1. But it is technically to the power of 1. Okay. Now the other thing that we did is we did this when we first learned derivatives, we turned things into polynomials before we learned product rule and whatnot. So we're going to do the same thing here. We can't take the integral of this, but we can turn it into a polynomial and then take the integral. So that's what we're going to do. So how do I turn that into a polynomial? What do I have to do? from pre-calc. You probably did it with these arrows. I don't know, did you guys call it foiling or did you just call it distribution?
You told us.
Okay. So we multiply the firsts. That's going to be 2x squared. We multiply the outsides, x times -3, -3x. Multiply the insides, 2 times 2x, so plus 4x. And then the lasts, 2 times -3, -6. Not quite there, because of course now I should combine those middle terms, so I'd get 2x squared plus x minus 6. And now I can go back to the fact that, okay, I'm going to take the integral of that. Do you need someone?
Oh, wait.
No? Okay. All right, so I'm going to do the integral of this now. So, 2x to the power of, add 1, I get 3, divide by the new exponent of 3. Remember, even though it's not written, this is x to the power of 1, so it becomes 2 over 2. If there is no variable, we add the variable, and then we add c. And I can't simplify this one at all, can I? Right? There's nothing I can do to actually simplify this. Nothing. Okay. So, let's let you guys try on this next one. So the first step is just to turn it into a polynomial. Okay? So I'm not going to talk it out, but I am going to write it so you can check your work. But try and multiply it yourself using FOIL or distribution, whichever. It's the same method, but so you can, like that. So I'm just going to turn it into the polynomial. You guys can look up. So then you can look and see if you at least got that part right before you start the integral. Okay?
Right, if it's 3x, it will be 3x squared, and then on the bottom 2.
But you have to add, oh, if it's 3x, yes. But I would combine the 3x and the -2x first before integrating. You'll get the same answer, but it's easier if you do it that way.
Cubed over 3 plus
Yep.
3x squared over 2 minus 2x cubed over 2 minus 2.
Okay.
Plus
So I'm going to do it with the combined version and show you it's the same. Okay? Because yeah, you could integrate from here, but if we combine them, it makes our life easier because I would get x squared over 2 minus 2x plus c. Now, or if we had just done it from here,
Would be the answer.
you'd get, well, technically you could simplify this, right?
Yeah, of course.
So I'd get 3x cubed
So,
over 3 plus 3x squared over 2 minus 2x squared over 2 minus 2x plus c. And these are still going to combine to be the same thing, right? It would just be 1x squared over 2. Yeah. Yep. So even if I do it that way that you did, it doesn't make a difference. I'm going to get the same answer once I simplify.
We
So
have to check.
again, only if I tell you to check, you should do it. But the point is, if you have like a little quiz or something, it's a good idea because you know if you did it right. Right?
a little quiz.
No quiz. You'll get one later. Don't worry. Oof, so angry at me.
Research already graded the other ones.
I'm almost done. Okay.
I have a question.
Sometimes we need to make equations look like polynomial instead of a polynomial. It can help us solve the really complicated ones. So when we have like fractions. So you'll remember we did this before we learned any of our derivative rules as well. So this is awkward. So my first step is going to be to turn it into a multiplication problem. So it's going to be the integral of 2x plus 3x, and remember, let's write those roots as fractions, times x, instead of 1/2, I'm going to put to the -1/2. Do you agree that this 1 over the square root of x is equal to x to the -1/2? Do you guys remember that from pre-calc? Right, our exponent rules. Cross the line, flip the sign. So the positive 1/2 became negative 1/2 if I want to write it on top. Okay? The reason I did that is because now, just like in the last one where we had to do some FOIL or distribution, I'm going to do that here as well. So, what is 2x times x to the negative 1/2? What do I do with the exponents when I multiply the base of x? I add them. So 1 plus negative 1/2, or 1 minus 1/2, is just 1/2. And if I have x to the 1/2 plus negative 1/2, it's 0. So it just goes away. So it's just going to be plus 3.
DX on the
And then the dx goes on the back. Yes, always. Now I can integrate. Now don't get freaked out just because it's a fraction. The process does not change. We still just add 1, divide by the new exponent. So this is going to become 2. What is 1/2 plus 1? 1.5. It's easiest if we leave it as a fraction, so 3/2. Actually, it's the same, but we should write it as fractions. Plus 3x plus c. Now I missed something here. What did I have to divide by?
by 2/3.
Kind of. You're on the right track. So you're trying to take the shortcut. We have to divide by 3/2. The shortcut would be to multiply by 2/3. Because if I have a fraction divided by a fraction, I keep, change, flip. Did you mean to do that, or was that an accident? You did it on purpose? Can you thank your girlfriend for that?
Yeah, of course.
Well, because she does that all the time in AP. Okay, yes. So our shortcut here would be to instead go 2x to the 3/2 and then immediately multiply it by 2/3. Okay? Plus 3x plus c. It's exactly the same. It doesn't matter whether you do it this and then go to there or go directly to here if you understand that shortcut because you're dividing fractions. Then I can simplify it for my last step. So here, this would become 4x to the 3/2 over 3 plus 3x plus c. Nothing else I can do. Okay? Amazing, yeah? Mariana, you're going to be okay. I think I made her cry. No, I haven't made anyone in this class cry. I think every one of my other classes, except BC, I've made someone cry. So, we're doing good. Unless one of you cried and didn't tell me.
Me.
Really? I made you cry. I don't believe you, Nicolas. All right, guys, let's get you to try this one. Now, again, I'm going to help you turn it into the polynomial first, but I'm going to do it without telling you to see if you can get it. So try and do it on your own and then look up. So what did I do last time? I turned it into multiplication. So start there. And I changed them into fractional exponents. Because if it's on the bottom, to write it on the top, I have to make it negative. And then I can distribute it. I'm going to have to do this on the side. I gave you guys kind of a tough one. Well, I got to combine 4/3 and 1/2. So I need a common denominator, right? Okay, once you've got it to there, check, and then go ahead and try to do the integration now. Check to make sure you did that part right. All right, let's see if you guys did it right. So, hopefully you got this part. It was a little bit tricky. You have to remember that like x to the 1/2 times x to the negative 1/2 is not 0, it's 1. This was a complicated fraction. But then we just need to integrate. So if this is 1, it just becomes x. Now here's the harder one. 5/6 plus 1. Did anybody get it? What'd you get? 11/6. Exactly. Good. And then I can either divide by 11/6 or multiply by 6/11. Because it's easier, in my opinion, to just immediately flip that fraction and multiply, right, Modest? Uh-huh. You're not supposed to have that, girl. Go put it away. Go put it away. Now, what's 2 times 6? 12. So I can write 12x to the 11/6 over 11 plus c, and that would be my final answer.
So right, y is x 1/2 times x minus 1/2 plus 2x.
Here? Because it would be x to the 1/2 plus negative 1/2. So in other words, we're solving 1/2 minus 1/2, which is 0. So you'd effectively get x to the power of 0, which would just be 1. And that's why I got the 1. Does that make sense?
Yes.
I think you're thinking subtracted. If you subtracted them, then they would add and become 1.
Isn't that last one?
That's the answer. And I think we're done, aren't we?
No,
We're done. You get time for practice.